So, good morning. I'm Navashri. I'll be presenting a case study on QoS evaluation in video streaming using Cisco Packet Tracer. So, this project it focuses on evaluating the important quality of service parameters such as delay, jitter, packet loss for video streaming applications using the Cisco Packet Tracer. So, coming to the agenda, these are the topics that will be covered in the presentation. So, introduction. Quality of service is commonly called as QoS. It's a network management technique that improves the communication quality by controlling and prioritizing the network traffic. In modern networks, many real-time applications such as video streaming, video conferencing, online gaming, and voice over IP, these applications they require stable IP and uninterrupted communication. So imagine we are watching a YouTube video and the video starts buffering. So this causes inconvenience. So this is because the network is unable to provide this consistent service. But so this problem is solved by QoS, which manages the bandwidth, prioritizes the important traffic, reduces the congestion, and improves the packet delivery. So QoS mainly focuses on the network performance parameters. So there are three parameters as I mentioned before. So the delay, the jitter and the packet loss. So delay it refers to the time taken by the packet to travel from source to destination, and jitter it refers to the variations in the packet arrival time. And packet loss it occurs when certain packets fail to reach their destination. So for video streaming, these parameters, they are extremely important. So therefore, by evaluating these parameters, it helps us understand the network performance. So coming to the objectives. So these are the objectives of the project. So first one, we are trying to simulate the video streaming traffic in a network environment. So the second one is we are analyzing the QoS performance by using the simulation tool Cisco Packet Tracer. Then we evaluate the network parameters, delay, jitter, and packet loss. So last one is we are understanding how the network traffic affects the video streaming quality. So these objects, they help us study the real world networking conditions. Coming to quality of service. So quality of service, it is a network mechanism. It's used to control and prioritize the network traffic. Not all network traffic has equal importance. For example, so video calls, they are more sensitive to delay, and emails, they can tolerate light delays. So QoS ensures that important traffic gets their priority. So the benefits include faster packet delivery. So here the packets reach destination more quickly. And coming to reduced network congestion, so here network resources they are managed efficiently. Then reduced delay and jitter. So real-time communication it becomes smoother. Then lower packet loss. So few packets they are dropped in between to enhance for better bandwidth. Then better streaming experience. Videos and audio they play without any interruptions, so leading to better streaming effect. So next, QoS parameters. So first one is the delay. Delay is the total time required for a packet to travel from a source to the destinations. So what are the causes of delay? So delay is caused by the network congestion, router processing time, transmission time, and the queue waiting time. So, for example, suppose a video packet is sent from the server. So, if routers take longer time to process the packet, the video packet it arrives late. So, this causes the delay. So, effects on the video streaming. So, delay it causes video buffering, slow loading, playback lags, and also audio video synchronization issues. So therefore, lower the delay is better and always desirable for the network communication. So next one is the jitter. Jitter is the variation in the packet arrival times. For example, there can be a packet number 1 which arrives at 10 milliseconds, packet 2 after 15 milliseconds, and packet 3 arrives after 8 milliseconds. So this variation is called jitter. Then causes. So causes of jitter includes variable network congestion, variable routing paths, packets queue fluctuations, different transmission times. So, what are the effects? So here high jitter, it causes choppy video, audio distortions, video freezing, and interrupted communication. So for a better and a smooth streaming, jitter should be minimal. Packet loss. So packet loss, it occurs when when the data packet is lost in between the transmission and it fails to reach the destination. So here causes like the network congestion, the full router buffers, the hardware failures, or the excessive traffic in between the devices. Then, what are the effects on the video streaming? So packet loss, it results in the missing video frames in between the entire video, and then reduced quality and audio interruptions and buffering. So in several cases, video communication may become unusable. So coming to the software and the tools used. So here the main simulation tool that I have used is Cisco Packet Tracer. So it's a network simulation tool. It allows us to design the network, configure the devices, and analyze the network behavior, and we can observe the packet flow. So here the devices used are PCs, laptops. These are the end devices which are used as client developers and also to generate and receive the traffic. Switches. Switches, these are the local network, they're used for the local network communications. And routers, these are used to connect network and forward the packets. So coming to the server, it acts as the source of the video streaming or the data transmission in this project. Then cable. So we have used copper straight through cables. They're used to connect the PC to switch and then switch to router. So they help in these devices together. They form the simulation environment. So coming to the network topology, so this is how the devices they are connected to each other. The topology consists of this one server, two routers, and two switches, and the client PC and the traffic PC. These are used to generate the traffic. So then working of the topology. So here the server, it acts as the source, and here the traffic PCs, they generate the additional traffic, and the packets they pass through the switches and the routers. So the routers then forward the packets towards the destination. So as the traffic increases, congestion occurs. This congestion, it helps us observe the QoS parameters, that is the delay, jitter, and then packet loss. So packet observation. So here the tick mark. So this shows that the packet has successfully been delivered, and the cross mark, it indicates there's a packet drop or a failure, and the colored packets, they represent the different like the different packets uses different protocols. So by observing the packet movement, we can easily identify which have the successful transmissions, the failures, and also the congestion points. So simulation mode, it provides a visual understanding of the network behavior. Then the role of the traffic PC. So here we've used two traffic PCs. So traffic PCs, they play an important role. So they are used to generate the continuous traffic. They are simulating multiple users and they create congestion. They are also used to test the network performance. So here with the traffic PCs, the network would be lightly loaded. So therefore, they help create the realistic network conditions in the environment. So coming to the advantages. So advantages of this project include this simulation. It helps in easy visualization of the packet flow. It helps in better understanding of the QoS concepts, and then simulation of real network behavior, then cost effective testing, and also these are useful for educational and research purposes. So Cisco Packet Tracer, it allows network experiments without the use of the physical hardware in the configuration. So it reduces the cost and also easy understanding. So application of quality of service. So quality of service, it's widely used in video conferencing. So here it includes the Zoom and the Google Meet. Then video streaming in its examples like YouTube and Netflix. Then voice over IP communication. So here voice communication over the internet. Then online gaming. So this will provide low latency communication, and then live broadcasting. So it ensures the smooth real-time content delivery. So coming to the demo, so this is the network topology. It consists of the network devices like the switches, the routers, the server, the PCs, the traffic PC, and the client PC. So here in our project, we have the video streaming. So here the server is used as a streaming source, and the client is it receives the service which browses it on the web browser. So now configuration. So these are being configured through the copper straight through cable. And then now we have the server which has the IP configuration 192.168.1.10. So this is the IPv4 address. And then we have the client PC0. We have the address 192.168.2.10. And then the traffic PCs, the PC1 has the IP address 192.168.2.20. And then we have the PC2 with the IP configuration 192.168.2.30. So these are the IPv4 addresses. So as we said, the server is the streaming source. We have the client which receives this, which browses the web, browses it through the web browser. So this is the part where the streaming is shown. So then now we come to the simulation part. So simulation begins with we are pinging it from the traffic PC1 and PC2. So here first the packet they're being generated at the traffic PC1 and 2. So here they are used to create the extra network traffic using the ping command. So here the traffic, it's not the actual video streaming one, but it's the background traffic which is used to evaluate the QoS parameters and the working. So now we'll start the pinging. So we've successfully pinned the value. So here now I was restarting the simulation. So we can see that the packets are being moved to the switch 1. So there's a delay happening. So it's taking time to move. Then it is forwarded to the router 1. And then to the router 0. Then to the switch, and it finally moves to the server 0. So here the packets are traveling through the network devices such as the servers and the routers. So this shows how the traffic is moving in a network path. So once they finish reaching the server, they're traveling back and they move to the client PC. So then the switch 0 is sending it back to the router 0, router 1. and then the switch 1, and then it has to finally reach the destination. So here it reaches traffic PC1 because here every ping has two parts, that is the echo request and the echo reply. So here the tick mark means that the packet has successfully delivered and a reply has come back from the server. So now again the packet is being sent. So here the crossed mark shows the packet has been lost or it is dropped. So this shows the packet loss. And then now it is generated at switch 0. It is moving. So there's again uncrossed. Now again it is generating, the traffic PC is generating another packet. It moves to the switch 1. So here different color of packet shows the different protocols that they use. So it's moved to the router 1. And then it is thinking where it should be forwarded next. So here we can see there are two different packets and they're moving at a different speed. So here the network parameter, that is a jitter, will be seen, that is they're moving at different speeds. So now one is at the server 0 and another one is the router 1. So they're moving parallelly. One is going forward and one is coming back. So once they are reaching the client PC, it shows that the client PC has received some data from the server. Before that, it will be moving towards the server and other PCs. So here the ping echo reply was being sent. So another packet is generated. So it's moving to the server. So there's another packet generated from the PC. They're together at the router 0. So now we can see there's a delay. They then start moving. So here it has returned back to the traffic PC. Its ping was successful. So there's one single packet which is returning back with the data from the server. So it reaches the traffic PC back. So here when the packets, they are moving from the server and they return back, it shows the request and the response communication. So here the client or the traffic device, it is sending a request. So the server, it sends a reply for the request. So now it is moving back. There was a failed packet. So here in this demo, so here delay, it can be noticed when the packets, they move slowly or they wait near the switches or the routers. So this happens here because there are many packets using the same network path. So due to this delay, so here the streaming may buffer or it may load slowly. So we can see one is returning while one has started slow and it is moving. So coming to the conclusion, so in this simulation, we understood that the server represented the video streaming source and the client PC acted as the receiver. So the traffic PC1 and PC2, they were used to generate the additional traffic to create the congestion effect in the new network. So as packets travel through the switches and routers, we observe the parameters, delay, jitter, and packet loss. So this demonstrated how network congestion affects video streaming quality and highlights the importance of quality of service in maintaining smooth multimedia communication. So the result of this simulation shows that by maintaining good network performance, it's crucial for modern streaming applications such as the online learning, video conferencing, live broadcasting, and entertainment streaming, which requires consistent packet delivery. So proper traffic management helps ensure that users receive uninterrupted communication and content even during periods of heavy network usage. Thank you.